In the last class, we discussed about nuclear fission and the energy released in a fission reaction. Today we are going to discuss about a fission reactor. Fission reactor is a reactor in which fission reactions are happened in a controlled manner. So we can use the energy released in a fission reactor for useful purpose. So that is a fission reactor. There are different parts for a fission reactor. The different parts of a fission reactor are fuel, moderator, coolant, control rods, shield, etc. Material used for nuclear fission is known as a fission material, or which is called a fuel for the fission reactor. So fuel is a fissionable material. Commonly used materials are uranium-238 enriched with uranium-235 and plutonium. So what is a moderator? It is the second part, the important part of a nuclear reactor. So moderator is a material which is used to slow down a neutron. We know that in a nuclear reaction, fast neutrons are produced, but they are not undergoing fission in a proper manner. So we have to slow down the neutron, and the part of the reactor which slow downs the neutron is known as a moderator. Moderator should have two important properties. Its mass should be comparable with the mass of the neutrons, and it have a low neutron capture property. If it have a neutron capture property, it will absorb the neutron instead of slowing down it. So it should have a low neutron capture property. It should have a property by which it can slow down the neutron. So a moderator is a material which is used to slow down the neutron. Usually heavy water and graphite are used as a moderator. In a nuclear reactor, the nuclear fission should happen in a controlled manner. So the extra neutrons which will cause the explosion, should be reduced. This is done by absorbing the extra neutrons. So the material used to absorb the extra neutron is known as a control rods. So the main purpose of a control rod is to absorb the neutron, absorb the extra neutrons. The material used for this purpose is cadmium, hafnium and boron. They are inserted or withdrawn from the core to control the rate of the reaction. Or using control rods, we can slow down or control the nuclear fission process. So they are known as control rods. So the control rods will absorb the extra neutrons, and the moderator will slow down the neutrons, fast neutrons. That is the difference between moderator and a control rod. The next part of a nuclear reaction is a coolant. In a nuclear reaction, the energy released inside the reactor is in the form of heat. The energy liberated by a fission reactor is in the form of a heat. So we have to remove the heat and utilize that heat for a useful purpose. This is done by a part is known as coolant. Air, water, carbon dioxide are used as coolant. So the coolant will absorb the extra energy or heat produced in a reactor, and it is then converted into steam, and that can be used to drive the turbines to generate electricity. So the coolants will the heat energy produced in a nuclear reactor is transferred to the coolant. For example, in the case of water, the water will absorb the extra energy, that is the heat from the nuclear reactor, and as a result of it, it will changes into steam, and the steam is used to drive a turbine, thereby producing the electricity. So that is the function of the coolant. It will cool down the reactor and remove the extra heat energy, and it will convert into steam, and it will this will leads to drive the turbine for the generation of electricity. So that is the main function of a coolant. Next part, let us discuss another part of a fission reactor, that is shield. So this is the shield, which is a type of material which will absorb the radiation produced by the nuclear reactions. We know that in a nuclear fission reaction, different type of rays are emitted, just like alpha, beta and gamma rays. Sometimes this may be this will cause serious health issues to mankind. So that will injurious to a person working near it. So in order to protect us from the reactions, there should be normally this shield is made up of a thick concrete wall. So in a normal nuclear fission reactor, concrete shield is used as, or concrete wall is used as shield. So this is a schematic diagram of a fission reactor. So here water is used as a coolant here. So here this nuclear fission happened here. As a result of this, the heat will generate, and the extra heat is transferred to the water, and it becomes steam, and steam will go to the turbine as a result of a generation of electricity. This will cool down and the water will reach here again. So this will, and due to nuclear reaction, huge amount of heat is produced. That heat will transfer this water into vapor, and the vapor is used to make turbine, to work turbine. So this process is repeating, and this is the basic principle of a fission reaction. So this is used to produce radioactive isotope, electric power generation, and source of fast neutrons. So that about the nuclear fission reactor. Next one, let us discuss about a breeder reactor. A breeder reactor is a nuclear reactor that generates more fissile material than it consumes. Normally, our fissionable material is uranium-235, which is very rare material. It is not so abundant as uranium-238. Even though uranium-238 is abundant, but it is not that much fissile. So the scarcity of uranium-235 is compromised by the use of breeder reactor. Here, in this reaction, in a breeder reaction, uranium-238 is used as a fissile material that will first converted into fissionable plutonium, because uranium-238 is not that much fissile material. So this reactor in turn convert uranium-238 into plutonium, and so the plutonium is a fissile material, and it will use to generate for the generation of the electricity. So here breeder reactor itself produce its fissile material, so we call it as a breeder reactor. So what is a breeder reactor? It is a nuclear reactor that generate more fissile material than it consumes. Okay, that is a breeder reactor.